Welcome back to UVA Data Points. I'm your host, Monica Manny. In his new book, The AI Playbook, Mastering the Rare Art of Machine Learning Deployment, Eric Siegel offers a detailed strategy for how business professionals can launch machine learning projects, providing both success stories where private industry got it right, as well as cautionary tales others can learn from. Siegel laid out the key findings of his book during a wide-ranging conversation with Marc Ruggiano, director of the University of Virginia's Collaboratory for Applied Data Science, a partnership between the School of Data Science and the Darden School of Business, and Michael Albert, an assistant professor of business administration at the Darden School. The discussion, featuring three experts in business analytics, takes an in-depth look at the intersection of artificial intelligence, machine learning, business, and leadership. So with that, here's Marc Ruggiano, Michael Albert, and Eric Siegel.
I'm Marc Ruggiano. I am the head of a collaboration here at the University of Virginia between the Darden Business School and the School of Data Science. And our collaboration is focused on topics at the intersection of data science and business, which is where I spent about 2.5 decades in the corporate world, working in various capacities that utilize data analytics and technology, primarily in areas that many people would call marketing. I also teach at the Darden School and here at the UVA School of Data Science. And so I'm really excited to be talking about machine learning with these wonderful colleagues. Michael.
I'm Michael Albert. I am an assistant professor of business and administration at the Darden School of Business. And I specialize in teaching topics around data science. I teach data science both to our Masters of Business Administration students and our Masters in Science of Business Analytics. My research focuses on the application of machine learning and artificial intelligence to economic problems, using things like machine learning to design new market structures, for example. And so I'm excited to be here as well.
Eric.
Okay, my turn. I'm Eric Siegel. I am a longtime independent consultant in machine learning for 20 years now, and I more recently spent a year as the inaugural Bodily Bicentennial Professor in Analytics at UVA Darden, during which, and I was the inaugural person in that position. It's a 1-year position, during which I had the pleasure of working with both Marc and Michael. And a lot of the work that I did during that year was the genesis of what's now become a book called the AI Playbook, which is just shipping virtually as we speak. And the topic of the book has to do with getting machine learning projects deployed, which is what I'm hoping will be a general theme of our conversation today.
That's awesome. And so, Eric, you mentioned machine learning projects, and with all the headlines and hype around AI, I think the definitions are starting to get clouded, certainly in popular conversations, if not elsewhere. So, what do you mean by machine learning, and how can we set that as a baseline for our conversation here today?
Sure. I think ML, machine learning, is well-defined. The value proposition is well-defined in contrast to AI. Machine learning is learning from data to predict. That's sort of an actionable definition of it, or practical applied definition. It's the application of machine learning methods like decision trees, log linear regression, neural networks, ensembles. You learn from data to predict in order to target operations, such as which individual customer to target for marketing or inspect for fraud, or which word to generate next in generative AI, which is built on machine learning. How to change a pixel in the next iteration during the generation of a new image with generative AI. So whether it's at that level of detail or another, it's at a fairly microscopic level, even in the business applications. And those are the more established ones. I suggest we distinguish from generative AI by calling it predictive AI, or predictive analytics is one way to distinguish it. Those are the established use cases, determining whether each individual is going to click buy, lie or die, commit an act of fraud, or what have you, in order to improve large-scale operations, because those predictions directly inform the action. the treatment taken with that very individual, whether to contact, to audit, whether to approve for a credit card application, whether to drill for oil in this spot, because not only human individuals, it's individual cases or situations, whether to check out the satellite, it might be at risk of running out of battery. So it's all those large-scale operations that are made up of many micro decisions. That's sort of the long-standing, established, proven track record of deployed enterprise machine learning, standing for decades. That's still where most of the money is and where most of the proven returns are. Generative AI, it's kind of like apples and oranges. That's a very exciting area. I fear it's overhyped, but I'm also extremely excited about it. And that's where it's, generative isn't a technical term. It's simply a reference to how we're using machine learning to generate new content items like writing and images.
Michael, what does that definition or does that description of machine learning resonate with you?
Yeah, I think that's roughly in line with how I view the definitions of machine learning and AI. I think traditionally AI has had the term AI has had a bigger focus on automated decision making, which I think is something that has gotten a little bit muddled and kind of popular usage. Eric pointed out traditionally machine learning has been more about prediction, though I think even that's a little bit of a gray area when you bring in things like reinforcement learning, which are certainly a subclass of machine learning. But traditional AI has often been concerned with how do we go about doing kind of optimal search within a space, or how do we go about making decisions based on uncertain data, which is certainly related to machine learning, but somewhat distinct. In the common discussion, I think that AI has primarily come to mean generative AI, which maybe is a bit muddled for our conversation. So I appreciate the distinction that Eric made with generative AI versus machine learning.
Awesome. So my take on it is that for the purposes of our conversation and exploring why machine learning projects aren't always as successful or even fail to deploy, the definition would exclude some of the things that we're reading in the headlines about artificial intelligence these days. What do you guys think about machine learning? It's been a thing for quite a while, and as you pointed out, Michael and Eric. But in my personal experience, there are many other things that have been around for a while and have gone through these cycles where it's a great new technology. It is expected and maybe even invested in to deliver great benefit. It doesn't do that, or doesn't live up to expectations at least, and people get disillusioned. And then we take a step back collectively and figure out, okay, how do we actually create value, with some of these tools and technologies? The deepest experience I have in that is in a thing called CRM, which was, the next best thing since sliced bread for, half a decade or a decade, gave rise to all sorts of, predictions about how amazing technology and data science were going to, change the way we interacted with companies and customers, and then fell into, what some call the trough of disillusionment. So, my 2 cents is that we've seen these things before. We've seen this cycle, and we ought to be able to do things differently as, in education, as scholars, as business leaders, et cetera. What do you guys think?
My mission is to save the world from that disillusionment, and I'm here to do that right now. So I think there's 2 layers of fog that are preventing us from capturing and realizing actual value in the successful deployment of machine learning, right? Which stands to improve, essentially virtually all our existing large-scale operational processes across industry sectors. And the two layers of fog are, first, the whole AI hype thing. And yes, AI is largely just a reference to generative AI in many uses, but it means a lot of different things. I think that the misleading narrative in public these days is that we're actively headed towards artificial general intelligence, computers capable of anything a person can do, including running a Fortune 500 company. You can onboard it like a human employee and let it rip. Let's just call it what it is. It's an artificial human. I think that there's a prevalence of belief that we're actively headed in that direction, even within decades. And I think that's a misbelief, and I think it's misleading. And for example, it means, hey, even if we only have 5% of it right now, whatever it is, that would be extremely valuable. So I think it's really important to quash that. The second layer of fog, though, even if you dispense with the sort of general mainstream hype and you focus on, so the antidote to hype is to focus on concrete value proposition. I'm going to predict which customers are going to cancel in order to target a retention offer that it provides a discount or incentive to keep customers around. One way or another, these predictive use cases are about triage, prioritization, the allocation of limited resources or time, and expenditure in order to run things more effectively. Numbers a business game, and this is the way to tip the odds a bit more in your favor. Now, here's the thing. Even if you've sort of cut to the chase and you have a pretty specific value proposition, predict X in order to do Y, predict customer churn to target offers, predict fraud in order to target the use of an audit team, or decide which transactions to automatically hold instantly. Whatever it is, that pair defines it, what's predicted and what's done about it. You actually need to get a lot more specific. So those projects, even as concrete as potentially and potent as they are, they fail to deploy routinely. The majority of new machine learning initiatives do fail to achieve deployment and therefore don't realize value. And I believe that the problem is a lack of proper planning, and that has to be collaborative from the get-go between both the tech and the business, the quants, the data scientists, and the business stakeholders, the person in charge of large-scale operation that's meant to be improved with the deployment of a model. Until now, there's been no established, standardized practice, framework, playbook, paradigm that's well known to business professionals. But you need a very particular specialized business practice to run machine learning projects successfully through to deployment. Most business professionals don't even realize that, let alone know the name of one. So what I've done with the book is I coined a 5-letter buzzword, and I'm here to evangelize it, and it's BizML, B-I-Z-M-L, the business practice for running machine learning processes, because there needs to be a brand around this concept, a buzzword, something where it's going to gain traction and therefore visibility and common understanding. We need a specialized, customized practice for running these projects. And I think that then we stand to actually realize on the promise of machine learning. Whereas, although there's lots of successful projects now, the majority of enterprises are behind big tech and a handful of leaders because there's this lack of universal understanding around the other half of each of these projects, the business part. That's what we need to get in place so that we can right now, there's the decades of track record of success and also even more failures. But we can we've sort of only tapped the tip of the iceberg, and we can really tap a lot more value. It is very practical and real. Machine learning is ready, and it's not about technological improvements. It's about organizational ones.
One of the challenges that machine learning faces in a lot of organizations is that traditionally the skill set to build machine learning models has been very kind of computer science, tech heavy, very statistics heavy. And the mindset to evaluate them, frankly, has been very economics heavy. And those two areas often don't really interact well. I would push back, and I'd love to come back to this later in the conversation. I'd push back a little bit on this idea that we don't have a framework. I think that there's room to improve frameworks, but I think there have been various iterations of frameworks in place. I just genuinely think it's really complicated. Even for example, I think Eric mentioned the example of customer retention, trying to predict churn so that you can do some kind of intervention to avoid a customer leaving your platform, your product, or whatever. One of the problems with that is that you can predict which ones are likely to leave, and that's a well-defined problem that we understand how to evaluate it. We can say strong statistical things about the quality of our solution, but once we add in the intervention, it becomes much more difficult to say whether or not our models provided value. For example, we probably already, as a company, if the hypothetical company probably already has some kind of customer retention strategy in place, right? I'm thinking of legacy cable providers. They already know that you have to call them.
Cable.
Yeah, they already know you have to call them to cancel, and they're already going to offer various interventions when you call, right? If they built a model to predict churn, it's unclear that would actually provide a lot of additional value because they have this existing layer, right? So you have to really view the quality of your solution primarily as how does it change the decision-making process, which is really a subtle question a lot of times, right? And I'm not providing an answer here. I genuinely don't know how we, really get machine learning teams, data science teams, and their managers and other business units to really focus in on kind of this broad decision question. That's what these models are feeding into.
Yeah, I think the challenge, to continue the example that you brought up, Michael, of the cable industry, which is perennially at the bottom of the list of industries as far as customer satisfaction, customer experience, and other things, which is not news to anyone in this modern day and age. But to continue with that example, right, I think one of the challenges as a business person involved in that effort that you described, the hypothetical effort, is to understand while we could build models that very accurately predict who is likely to churn, who is likely to leave, we can't accurately value all of the possibilities that we might do to keep them. At least, we could, but it would take an extraordinary amount of time and money and other things that, in a limited resource environment are likely better applied against other business opportunities. So, that business person is put in a position of having to make a judgment, even with an extraordinarily well built and tested and proven model at their disposal. And I think that getting the data science team and function and practice and discipline more integrated with the business practitioners across the board, whether it's marketing, operations, et cetera, is one way to bring that together. We can't make everybody an expert at everything, right? But we can't also put the full decision and all of its complexity on the shoulders of someone who is only an expert in one area. So how do we strike that right balance? I think that's one of the areas where education and management practice can improve.
Yeah, I mean, that's a great way of framing sort of what the issue is. How do you balance it? Not everyone can know everything. My assertion is that we need to get the business side stakeholders to ramp up on a very certain semi-technical understanding, which consists of what's predicted, how well, what's done about it. As I mentioned, what's predicted and what's done about it is sort of the way those are the ingredients that define a particular use case. How well, the second of those three, is the metrics. And you have to get involved in a certain amount of detail. It's not the rocket science part. It's sort of understanding how to get value of it. So I'll circle back to my assertion that there needs to be a broadly adopted, broadly understood business paradigm. I totally agree with Michael that there's been plenty of attempts at frameworks, one in particular that's well known well known amongst many senior data scientists, called CRISP-DM. But my assertion a moment ago, just to clarify, and I'll say it more emphatically, there's been no established standardized practice that's well known to business professionals. And this is a business practice. It's the business professionals who need to know it. And that way, CRISP-DM, by far the most successful one in the past from 30 years ago, has the word data mining in its name, has never been updated, failed because it's not well known. And again, I think that even business stakeholders don't even know that you need a very specialized particular framework or practice in the first place, let alone the name of any particular one. So what I advocate for is however you break down the life cycle, and I break it down to 6 steps from inception to deployment with the BizML thing. But however you break it down, the more important thing, the bigger theme, is to get that deep collaboration and have the people on the business side of that collaboration having had them ramp up on the semi-technical understanding. And but I say what's predicted, how well, and what's done about it, I mean to a really concrete amount of detail. For example, not just who's going to buy or who's going to cancel, but which customers who've been around for 4 months are going to decrease their spend by 80% in the next 3 months and not increase their spend in another channel because that wouldn't count as a defection, et cetera, et cetera. All the caveats and qualifiers that are business relevant, maybe 3 times as many as those I just spat out, to define that prediction goal, otherwise known as the dependent variable. And to get concrete. So the examples you gave where there's this trickiness of how do you know whether marketing worked, right? Well, you should have a control set, but listen, what I'm advocating for isn't necessarily sufficient, but I would argue strongly that it's necessary. We got to get them on the page in that concrete level of detail so they understand, okay, with targeting response model, you're predicting customer purchase in light of contact. With churn modeling, typically you're predicting customer defection in light of no contact, right? And Michael, you and I wrote an article together on that. Let's see, I'll remind myself the title of it. I have it right here in Analytics Magazines, run by Informs. To avoid wasting money on AI, business leaders need more AI acumen. And then the example we get into is the difference between targeting marketing versus targeting sales, where with sales, you're not going to necessarily be controlling the treatment of customers in that data collection in the same way. So you have to be very specific. For targeting sales, you might be predicting, will the individual buy, given how the sales team has previously interacted with them. Whereas for marketing, you're predicting, will the individual buy if contacted with this particular marketing treatment. So those are the kinds of things we break down. And the problem we're identifying in that article that we co-authored is that lack of business understanding of the particulars there. Again, I don't know how to solve all the world's problems as much as I facetiously said so up front, but I am arguing that these are necessary, even if not completely sufficient conditions.
Well, so I appreciate you bringing up the article, because I think that in that article, kind of one of the things that we pinpoint, and this is a bit of a technical term, is the distinction between kind of predictive machine learning and causal machine learning. This idea that things might be correlated, and therefore you can predict, that something based on whether or not something's correlated, but it's not. That's often at least orthogonal to what a business leader really cares about, right? I think a lot of times
you want to make people buy.
Yeah,
ideally you want to make people not do fraud, but that's not usually the objective. Those projects are just about how do we balance false positive and false negative rates as far as blocking, credit card payment transactions. So you don't have to worry about causality as much with those projects.
And I think that we have seen huge successes in machine learning on projects where we don't need to worry about causality, right? I think fraud is actually one of the best examples of machine learning applied to industry, right? Fraud detection for credit cards. It's maybe the biggest success story for the traditional machine learning. I think the problem is that there are actually relatively few questions that are as nice and simple in business as like, as well defined as predict fraud and just decline the transaction, right? And even that, I think, there's subtleties involved where you could imagine not just declining, but doing some other kinds of treatments where you might start to get into, concern about causality. But I think, going back to this example of sales versus marketing, I worked with a company that had they had data on their salespeople, and their salespeople, they then had data on conversions for leads that were reached out to, and they wanted to build a predictive model to evaluate how likely a particular potential customer would be to convert. The problem is that the model that they built had encoded the behavior of the salespeople, and so there was no real way for them to alter business practices without making their model completely invalid. They couldn't predict the counterfactual, right? And I think that's where most of the time what we really care about is we care about understanding what if I had done something different, and that's a really subtle question that I think people struggle with. I think I teach a class on data science here at Darden, and I spend a lot of time. We go into a lot of technical detail. We have extremely sharp students. By the end of the class, I still think most of the students struggle with this distinction. It's just challenging. I don't know if you guys have thoughts on ways to raise awareness of kind of the limitations of traditional ML. And there are ways to get around it, including costly ways, experimentation, things like that. But that's a harder sell than, I can run this Python code and come out with a deployable model, right?
Well,
I'll just make one quick comment. The CEO of Harrah's Casino is famous for saying he'll fire anyone who steals from the company or fails to use a control set.
Good, well done.
it's Harrah's and Caesars are great examples of a lot of this sort of enterprise transformation that perhaps underlies the more effective, development and deployment of machine learning. And so I'm glad, Eric, that you bring that one up. But to take a half step back, when we talk about the difference between sales and marketing as one example of how business practitioners' thinking needs to advance in terms of their understanding of how best to integrate, to incorporate machine learning, and on the opposite end of that spectrum, how a data scientist, even a senior one, their understanding of sales and marketing needs to advance. Right, the contemporary practice of thinking about sales and marketing together is to not think about them as distinct fields, distinct activities, distinct motions in a corporation, right? A sales outreach is just a different channel, and it can be broken down into all of the same constituent parts that any other marketing interaction could be broken down into. And so, what is different is the fact that a human being delivers the sales interaction, right? And we can't quantify every aspect of that behavior and every impact that potential customization may have on the outcome of the interaction. Whereas a digital ad,
it's called a control group, and it's much easier to control machines that do marketing than humans that do sales.
And that's a great example, right? To a business person, having a control group or a holdout from your prospect list is throwing opportunity perhaps down the drain, right? Why would I not call on 10 or 20% of my prospect list because you need a control group, right? Mr. or Ms. Data Scientist.
Yeah, right? And that's why I also
vetoed.
don't use
Come up with
sets.
Another alternative. Come up with another way we can do this.
Yeah. Wah, wah, wah.
Exactly.
I mean, there are I think in the realm of kind of academic research, there are alternatives, right? There are ways in which, with careful measurement and some kind of understanding of the situation, we can draw causal diagrams and use, kind of advanced tools to estimate these causal effects without control groups, assuming there's enough variation among some dimension. But I would say that, there's still a ton to get wrong there, right? And it requires a really subtle look at the situation. And control groups make that all easy. It's not strictly necessary, but like in the article that Eric referenced, I went back to the company after seeing what their data looked like, and I suggested they collect some more data around the behavior of their sales team in order to do this, in order to try to tease out these causal effects without having without having to run these costly experiments. But data collection is itself costly, and they never were able to actually collect the data needed. And so, I think, it is. You have to have buy-in from the beginning of the project, right? You have to have people who say, I understand enough about the issues to understand why you need this data. I believe in the final outcome, even though I don't know what the data is going to say, right? So like whatever the final outcome might be, that it turns out this problem is unpredictable. We built our best model and we've got really no statistical power here. But you've got to make all that commitment and investment up front before, people start just building predictive models that really aren't well suited to the decision problem.
It sounds like we all agree that it's harder with sales and marketing, but if it's marketing and you have a control group, isn't it reasonably straightforward to at least establish how well your marketing campaign did?
Oh yeah, I agree with that. But again, the cost is that you're burning some subset of potential customers, right? And that with that control group, that's a sell you've got to make to who's ever deciding whether or not that's okay, right?
And I would add, Michael, I think for that person who is deciding whether it's okay, right? That person, that individual needs a deeper understanding of what was done to demonstrate, the effect that either they're looking for and not finding, or the effect that they're trying to agree just happened, right? They're trying to confirm. And I think one of the things we're saying here is that, there are steps that, leaders in education, leaders in the corporate world, et cetera, can take, to improve their ability to do so. And, I think one of those is certainly, for the business leader in question, who's being asked the question you just posed, they need to understand the methodology, the technique, and the interpretation of those in order to make a well-informed business decision. And most business leaders, in my experience, are not yet fully equipped to do that.
Let me argue something slightly from the other side, right? I mean, we could expect, the C-suites of modern companies to become, amateur, machine learning engineers. In my experience, that's a pretty heavy lift. The other side of it, and I think that is something that certainly I'm working on with the students that I teach, and I think the School of Data Science is certainly very much engaged in, is training our data scientists to be better at communicating the value. To be better at thinking about the big picture, to be and to be more winsome in how they ultimately deliver the results to the stakeholders. This puts the burden on the data scientists, where they have to be really clear about, when they're presenting the outcomes of their prototype model to their CTO or whoever else. They've got to do a lot of education. They've got to help them understand what the limitations of the modeling are, what the challenges around, making good decisions with the model are. And so I guess there's a question, do we think that it's likely to be more successful kind of going kind of top down in building up this bridge, or going bottom up and building up this bridge?
So can you spell that out for me? What's the metaphor?
Yeah, so I think we've been talking a lot about how decision makers in business need to tech up, right? They need to become more aware of what machine learning models are doing, what they're not doing. I agree with that. I just also know from experience that that's not an easy task, right? Somebody who's well established in their career, like, it is actually quite challenging to, while some of the concepts to us all seem very simple, to lots of people, these are very difficult concepts to grasp, right? And so the alternative would be to put the onus of understanding and communication on the data scientist, right? That they have to come to the decision maker with a compelling demonstration of value, right? That they and a easy to understand view of the trade-offs and challenges associated with implementing these models. And so, the question is, do we go bottom up by training the data scientist to be a more effective communicator to the decision makers, or do we go top down and try to train the decision makers to be more effective data scientists?
Yeah, I mean, did you see the Indiana Jones movie? I mean, people on both sides of the chasm have to do something to get across it. Like, both sides have to participate. I think that whoever's selling the project, that sometimes is the data scientist, does have a responsibility to take a more business-sized role. I mean, everything you just said, I totally agree with, and I think it's a little bit of an uphill battle often to get data scientists to recognize the need for them to take a more business oriented role, to expand outside their cubicle and take responsibility on that level for the communication and for guiding the project in that way, in a meaningful way, especially if you're selling it in the first place. One of the failure stories I tell in the book is my own. Early in my consulting practice, I had a big successful online dating site, and I said, hey, churn modeling, you've got these premium paying customers. Look at how many, there's a high churn, so many coming in and leaving every month. If you just can predict which ones are defecting, you can target retention and potentially have a very effective, financially effective method that really increases your lifetime values and all this kind of stuff. So I did and they were like, cool, that sounds great, right? I mean, they were so flush with cash, and all of a sudden, as a brand new independent consultant, I was getting 3 times the hourly than I'd sort of even imagined. And I was like, this is great. I'm doing churn modeling. I'm actually using this stuff in the real world for a real world problem. And then, of course, the power gets stuck in PowerPoint, right? That's the traditional thing. So I present it to them, and I'm like, da-dun-dun, da-dun-dun, and I show a clip of the decision tree, and here's all of the projected returns if you target a retention campaign. Of course, when you project the returns, you're a lot more speculative for targeting churn modeling than for targeting response modeling, namely for the reason I mentioned earlier. You're predicting what would happen in lieu of contact rather than in light of contact, and that makes a big difference, because then you have to assume, okay, well, even if you contact the right person, someone who is destined to leave, what are the chances you'll change their mind? And if you do, how much longer are they going to stick around, right? So there's all these assumptions without a control set, right? So I presented it to them, and they're like, cool, you want us to do something about it? You want us to start a new initiative, a new marketing campaign? Right? They were too busy. I hadn't sold the project properly. I'd sold the number crunching intrinsically. They didn't get there's an operational deployment part of it.
Well, so Eric, I'd like to just ask a quick question, because I thought you're going a different way with the story. It seems like churn is the goal of a dating site, right? That you should the hope.
No, this was actually, let's just be completely transparent. You can read about it in the book. This was gay.com, which at the time was a male hookup site. So it wasn't about true love forever. It was an online service. And besides, even if you're a more traditional online dating site, my father was a psychiatrist, and we would always joke about, you want to cure your patients, but not entirely, right? You're going to lose their business.
Yeah. Well, I mean, there's one of I had a student who worked with in his job, he worked with a data science consultancy. They were a big mining company, and this data science consultant came back and said, you could improve your operational efficiency by making sure that you don't run the mining trucks empty half the time. And when they told him this, everybody laughed at them because they're a mining company, right? You've got a big pit you're mining stuff out of. You drive the empty trucks down the pit, and then you drive the full trucks out. And so there's, it was an example that stuck out to me as a particularly egregious one of not seeing the full context. But I agree that that in your particular example with the dating website, yeah, it's churn modeling is a perfectly valid thing to do there.
Yeah.
And how would you, and Eric, how would you, to generalize that, right? How would someone in the position you were in at the beginning of that story know the business well enough to be able, even if you were so inclined, to modify your proposal, to account for the fact that this is a site where people don't stick around by design? And, to me, that reinforces the need, whether it's driven top up, top down, or bottom up. We haven't dug into that yet. But either way, it reinforces the need for, that sort of common understanding to grow, right? The data scientists knowing more about business and vice versa.
Eric, I'd love for you to run down kind of why you think that BizML is likely to be a widespread playbook for AI, right? Like, what does BizML have that the crisp DM that you referenced earlier? Like, how is it likely to succeed where that has failed?
Well, first of all, BizML is specific for machine learning. Crisp DM is sort of data mining in general, which is subjective, same as data science. Basically, number crunching, using data in a meaningful way. Whereas for machine learning in particular, where you have to define the dependent variable, that is to say exactly what's being predicted, and then in the deployment, you're actually going to integrate those predictions so they change existing operations. That means driving business processes with probabilities, right? That's really what it comes down to. Those are very particular things, and those are interweaved through the 6 steps. I mean, the 6-step breakdown is pretty straightforward, and I'll outline it. But let me just say, what really needs to happen right now is the packaging, so it's done in a way that it is understandable, relevant, and interesting to business stakeholders, which includes, amongst other things, a really nice 5-letter buzzword, BizML. And then therefore we can put on the radar of the broader public that are touched by or even involved in any way with machine learning projects, which is only growing, that population, the need for a particular business practice, just the need for it, the knowledge that there is one that's being generally adopted, and maybe even more importantly, that you need to get business side stakeholders involved in that level of detail, not the spark plug under the hood, but how to drive a car, momentum, friction, rules of the road, and mutual expectations of drivers. That's a lot of expertise to drive a car. Same level of semi-technical understanding for business side stakeholders to run a machine learning project. So the understanding that they need to ramp up on what's predicted, how well, what's done about it, to get into the details. If they don't get their hands dirty, their feet will get cold, right? Get into those details in the process from end to end of the project. That's the important thing, right? Now, the breakdown into 6 steps, some do 5, some do 8. I didn't include monitoring or maintaining up refreshing afterwards. I mean, I included in the book, but in terms of the 6 steps, it's culminating with let's at least get the thing deployed and make it plausible that it could be deployed. The 6 steps break down in a way that to most data scientists, when you think it through, is really quite obvious and is along the lines of what people already sort of formalize it as. The main thing is to now convey that breakdown to business stakeholders. And anyway, the first 3 correspond to those 3 semi-technical facets. What's predicted, how well, what's done about it, but not in that order. So predict a deployment goal, which is what's predicted and what's done about it. The first step is to establish the deployment goal, which is what's predicted and what's done about it. That pair that defines the use case, the value proposition. The second is to get more specific about the what's predicted part and flesh out the full definition, semi-technical details of the dependent variable, the thing that you're predicting. And then the third is the metrics, which have to not only be technical, but business metrics, like a way to forecast the actual returns or profit of the operation or the operational improvement. So those are the sort of pre-production. And then the other three steps are what everybody knows if you're a data scientist, which is prep the data, train the model, and deploy it. So what this is really about is not so much those 6 steps, but hey, let's bring the other side of the company into those 6 steps.
I think, Eric, I think the 6 steps and BizML, I think are a great proposal, and I am hopeful that the adoption, is there in the practitioner and academic communities. And to connect it back to, what Michael asked us a few minutes ago to wrestle with, how do we get all parties in, an enterprise on the same page, and where that page, contains more insight and understanding about the business and about machine learning. Right? These 6 steps, BizML, is a process that ensures that those stakeholders come together and realize when each one or the other don't know enough, to proceed. And they can be educated by, the person proposing the project, or, the vendor or the team internally that, is bringing it forward. But by having a set of steps like this, like BizML, we're able to have a built-in sequencing of interactions among all the stakeholders on a team, on a project, in an enterprise that need to come together. And those interactions will point out where the gaps are in knowledge and understanding if people enter into them, in an open and collaborative way.
Yes, hallelujah, right? That's what I'm saying. That's what I mean by deep collaboration on end-to-end on each of the steps. Exactly.
And I think that, to me, that bridges the gap, crosses the chasm, solves the problem in the Indiana Jones movie of, top down versus bottom up, how to bring the two sides together. They are together because they are all bought into this set of activities that you've christened BizML.
I'm curious. A number that's often thrown around, something like 90% of machine learning models are never deployed, or 90% of machine learning projects or whatever are never deployed. I'm curious, in your guys' view, is that 90% driven by? It's certainly some of both, but is that 90% primarily driven by data scientists making useless models? This would be, similar to the sales example that we talked about, where this company had built a model that was useless, and they didn't realize it was useless, but it was useless. Or is it the stakeholders being unable to evaluate whether or not a model is likely to be valuable?
I think it's more the latter. I think that, but they kind of go hand in hand, right? If the business stakeholders aren't guiding, then the data scientist they haven't defined the dependent variable specifically enough, aligned with the exact deployment plan. But the deployment plan's concept is moot because it wasn't fleshed out enough to have business stakeholders really understand, hey, I'm going to actually change my largest scale operations in a substantive way with probabilities. So by the way, though, that 90%, I kind of hear 80% thrown around more, but that was actually one of the 3 main prongs of my work during my analytics professorship at Darden, was industry research. And I hooked up with Rexer Analytics that does a big data scientist survey, kind of convinced them to add questions about deployment success rates. And the results were that only 22% of data scientists say new analytics initiatives meant to drive new capabilities usually deploy in the sense that 80% or more deploy. So it's not like how many of your models deploy, it's how many data scientists say at least 80% deploy. It breaks down like that. We've written it up. It's on KD Nuggets. Across all initiatives, not just sort of new capabilities the way we defined it there, it was more, but only 43% that said that 80% or more. I'm sorry, let me correct that. 43% actually say 80% or more fail. So, and by the way, the failure rates that we're talking about, if you try to estimate that into what it is as far as the number of models that could be deployed that aren't, are actually similar with just digital transformation initiatives in general. Like there's across a lot of other kinds of technology, there's a lot of reports with similar difficulties. But my assertion is for machine learning in particular, you need to get into those kinds of details about what does it mean to drive. Ultimately, what does it mean to drive operations with probabilities? What do you need to predict to that end? Probability of what? That's the dependent variable. What data do you need, right? So those details and getting the business stakeholders in there. And I think that it's a lack of deployment. It's sort of like the question is the business unwilling to or can't because they need more ML ops infrastructure or more data pipeline infrastructure? Either way, it's a lack of planning. So I see it as an organizational problem that can be addressed by better planning.
Yeah, in my last corporate role before joining UVA, I was responsible for a team of modelers and other folks, and I would say that I didn't actually tally this up, but I would say that less than 10% of the modeling projects that the team had undertaken over, my tenure there, were in active deployment. And, I think, the survey type responses that we hear, including the ones you mentioned, Eric, are points in time. And obviously, if we aggregate those, over some period of time, we can probably come up with any percentage of failure that we want, depending on how we combine those numbers. But my team, they didn't. Our projects did not deploy for a couple of reasons. One of those, I don't think we've spent a lot of time talking about here today. That is, they weren't designed for broad deployment, right? We have a team. Many organizations have teams that do a lot of exploratory work, right, to understand and probe where the opportunity exists for the business, or to demonstrate feasibility, to narrow down the approaches that should be invested in, to address a problem. And, when you...
Yeah, just to clarify, we did in the question posed to data scientists, of the models you developed with the intention to deploy.
Yeah, exactly. So that qualification is a very important one, as is the work that a data science team might be doing on things that are not intended to deploy, right? Those are oftentimes very very valuable as well. But the second reason, and I think you touched on this, that my team had projects that didn't deploy, is the failure to for the organization to recognize that this wasn't just a model, this was a transformation of how we did something major. Right? If it's going to have major impact, it has to influence something very significant that the company is doing. And, to think that a group of people are going to sit, in a lab-like environment for some number of months and come up with something that completely changes the fortunes of the company, right, without having to get everyone else involved is, a fundamental misunderstanding, right? And so the main reason why a
common one.
Oh, yeah, absolutely. And, it was the reason why a number of our projects, despite our best efforts, didn't go forward, because people loved the possibility and were turned off by the work that would be required to realize it.
Well, this is the best technology. And I only mean that half tongue in cheek, right? It's the why, probably you guys too, I'd say most techies, myself, I got involved in this because the core technology, the idea of learning from limited number of examples to draw generalizations that hold, that pan out in new unseen situations. In that sense, the computer is automatically learning, is the best kind of science and technology. It's the coolest. It's the most fascinating and potent and interesting. And the Harvard Business Review calls it the most important general purpose technology of the century, or something like that. So we're using the best technology. Of course, it's valuable. And that misconception, I call it the ML fallacy in the book, that misconception that it's intrinsically valuable, rather than the value, in fact, only coming when you act on it, when you deploy it, when you use it. That's sort of like because we're fetishizing the technology. We're in love with the technology. It's like being more excited about the rocket science than the launch of the rocket.
Interesting. So what do you guys think we'll see? If everyone listens to this podcast, as I know they will do, and takes the lessons that we're sharing and reads the book and takes those lessons home to their educational institution, to their corporation, et cetera, right? Machine learning and the way we use it and experience it today, regardless of what side you're on, is going to change, right? What do you guys think the future is for machine learning and for the people who are engaged in it as users, as developers, or anywhere in between?
I mean, I think Michael made a great point that on a certain level, we can't hope for any sort of clear-cut silver bullet where the really intractable challenge is getting, especially when control sets are needed and what it means to define them, experimental design, where that's so hard. What I'm advocating for, of having a common language, understanding brand on the need for the practice, calling it BizML. Again, honestly, I see what I'm advocating for as necessary, and yet I have the humility to say it not necessarily sufficient per Michael's concerns. A big part of those concerns, by the way, kind of come from the fact that with a majority of these projects, we're using found data, right? It's sort of like longitudinal studies rather than controlled experiments or any experimental design. And that's sort of what all the excitement about the big data movement was, is you're collecting this data residually. It's like a side effect of conducting business. All the transactions are getting logged. It's experience from which to learn. Let's leverage it. So the big and big data, we're going to run out of adjectives, big, bigger, biggest, because data grows so quickly. But the real, what that word big is about, the excitement, the potential value of found data that's already been collected anyway. But when you do that, you don't have a control set. You deal with a lack of causality. And when you go to certain applications like marketing, it can be really tricky, especially if there's a refusal to have a control set on the deployment. So that is an unsolved problem. I worked hard to scope out a book that's, not much longer than 260 pages, right? So that if you see it in an airport bookstore, it's not going to look too thick for your next flight, which means that although I covered a lot of ramp up for business readers on what I'm saying is semi-technical understanding, I don't get into control sets in that book at all. I do in my first book.
Yeah, I mean, one of the things that I think we're seeing, and I have mixed opinions about this, is the democratization of data science. Historically, the technical skills required to use these tools have been relatively substantial. Now, frankly, I can, with a ChatGPT Plus subscription, I can go armed with a CSV file and ask ChatGPT to write me Python code, and then run the Python code and show me graphs and give me all sorts of, fairly good from a technical perspective models based on this data. It's very easy. Frankly, I think what we're going to see is more and more people engaged in the process of building predictive models. Which is good in many ways, but I think that the flip side of having a significant technical barrier to entry to building these kind of models is that you also had generally developed statistical skills and some sense of experience and perspective that can help evaluate what you've produced. And I think that this this newfound access to these, very easy to use kind of modeling tools. And I'm not including things like AutoML, though that's another discussion, that can build these really accurate predictive models with almost no effort. I suspect we're going to see a lot of bad modeling out there, right? I think that, I think that we're going to see a lot of people, run with these machine learning models because they are this wonderful technology without understanding the context in which they're going to be deployed. I think that's...
You're saying, when you say you have mixed feelings about democratization of data science, do you really mean that, or do you mean that you're mostly have a negative? Because I would say I'm mostly negative. I'm more like, oh, gee, you do need some expertise. And just to be clear, when I say semi-technical ramp up and collaboration, I'm saying that's a necessity on the business side, but you still need the data scientist human.
No, I actually say I have ambiguous mixed feelings about it. I think that there's a lot of opportunities for people to ask questions that the typical data scientist just would never think about, right? Because that's not their functional unit. There's a lot of opportunity within an organization for people to experiment. I think if there's a gate before deployment. Fortunately, I'm not sure that, especially in small organizations, I'm not sure that there will necessarily be this gate before deployment. But if there's a gate before deployment, I think it could lead to kind of a creative flourishing within the kind of machine learning space in a lot of organizations. Whether or not that happens is an open question. But I mean that's why I have mixed feelings. I think democratization of tools, is generally a good thing. It's just that there's these powerful tools need to be wielded carefully.
Yeah, indeed. And the ability to use ChatGPT to make the Python code doesn't really introduce a new element to that, maybe increases the prevalence, but there's already been longstanding paid commercial sort of super user-friendly tools. I always call them PhD tools, push here dummy.
Yeah, on this topic, I'm probably a little bit more extreme than either of you. I think that the arc that we have seen in many technologies is the same one that will happen, that is happening here. And if you think that not needing to be able to rebuild the engine on your car, is a good thing, then not needing to start from a blank screen and write your first line of code, or not needing to start from, a statistical theory and figure out how to implement it, those are also good things, right? But to the same, on the same, by the same token, right? It doesn't mean that the car engine doesn't need maintenance. It doesn't mean that someone shouldn't have the expertise to make sure that the theory is translated into a tool with high fidelity, right? Or that the output is meaningful and used appropriately. Right? But I think we're all going to see many of those safeguards also built into these same sets of tools, right? In the same way that some of the commercial tools today warn you about problems with your data set or issues that would make one technique more appropriate than another, right? And people who might not be able to discern those things themselves, can see the warning and either figure out what to do themselves, or they can bring in an expert. I think those are the types of things that are on the horizon, right? Where the expertise that is resonant in a data scientist who is a trained professional, can be applied at the top of the data scientist's license, so to speak, right? And not have that data scientist be doing the kinds of things that are becoming everyday things. And that, again, that push and pull, to me, is something that's embodied in and will happen if both sides, all stakeholders are following a process, a set of steps, that are most appropriate for these projects. And I think, BizML offers the opportunity for that.
So I think the example of a car is interesting because we do have driver's tests before we let you drive your car, right? You do have to understand something about a car. You have to understand how to operate it. You have to understand what makes it safe, what makes it dangerous, right? You have to demonstrate to somebody that you can use it with some care. Back to this article that Eric and I wrote. This organization I was working with, I went to them and I explained to them that their model, I was the gate, right? That their model did not learn what they thought it had learned, that predictive power did not translate into value here, and that they needed to do additional data collection. And the response that I got was that if we don't build this model, marketing is going to build it because we're very focused on ML, and we want to control it. And so we're building it. And as far as I know, that model is deployed right now. And so there's, I think
sounds like a bad client.
I did my part. I explained to them very clearly that this was not that this model should not be deployed. I went to the boss of the person who I was directly working with at this organization to explain this, and it still got pushed through. And so I think there is a danger here, right? That these things, none of the tools will ever. Data is agnostic to causality, right? And you can't understand the context purely from any given data set, right? So it's going to be impossible for any of these automated tools, any of these AutoML tools or ChatGPT or anybody else without the business context to ever provide a safeguard, right? Because it's just not, it's not even theoretically possible. And so, I that's where my concern comes in. I agree that needing to know how to write Python code is unnecessary, just like needing to know how to rebuild your engine is not necessary.
For everyone,
right? That. But I would say that some element of these building and particularly deploying these models is actually more akin to driving the car, where it is important that we evaluate somebody's capability of doing that.
I would agree, and so like I said, I think I'm a bit more. Out there on that issue than either of the two of you are. But I would certainly agree that where we are, today in 2024 is not a place where, all the risks have been addressed. And so there are absolutely challenges and risks. And, I think in our environment at UVA and, in other contexts, where people are reading your book, Eric, there are a lot of business risks that are, growing because these tools and these techniques are more accessible. But I'm an optimist, and I think that through education, training, literacy efforts, by putting in better processes that bring together data science experts and domain experts in business and other fields, in an organized way, like we've talked about the 6 steps that we've talked about here today. I think I'm an optimist that those steps will ameliorate the risks and begin to unlock some of the power of machine learning and AI more broadly.
Yeah, I agree. I'm optimistic. I think that Michael's story should be qualified because, there's always going to be organizations, especially smaller ones in this case, right, where they act on superstition, right? They also hire a clairvoyant and they avoid stepping on cracks on the sidewalk, and they think that's going to help their business, right? There's always going to be situations where they just don't listen to the expert. But I think that we're moving more towards data-driven culture and the understanding of that expertise. I think that we need to make sure that the technical side of the projects are conducted in a more sound manner, but that the first more fundamental, generally missing piece is an utter lack of a business side process.
Interesting. So my final comment is, and see if you guys agree. But we've mentioned a few things, throughout this conversation that even in our programs here at UVA and in other training and development initiatives, even in the companies that I've been a part of, are just not front and center. We've mentioned the difference or the level of difficulty difference in collecting data that is, specifically and most relevantly applicable to a particular challenge versus using data that's been collected over time for some other reason or for no reason at all. We mentioned, increasing the literacy in experimentation and causation. We've talked about, the importance of ethics and ethical use and application of, data science and machine learning and these tools. And we've talked about the driver's license concept where, we have a hard time today in business and elsewhere agreeing on, who is a data scientist, who is a machine learning engineer, and what qualifications do you have to have in order to be called one, right? And without that, you can't have a driver's license. There's no such thing if there isn't a driving test. And so, we have those challenges, and I throw those out there for you two guys, because I think those are challenges that, that we need to be at the forefront of tackling, whether it's through books or education or in other means.
Yeah, I feel like that's a burning question that I'm to this day agnostic about. Is, how should it be regulated or formal? I mean, there's actuarial standards for an actuary, right? But not for data science. And I see pros and cons. I don't know who's going to do that, how, and how it's executed. Obviously, would be important.
Yeah, you've got me. I mean, more people should sign up for advanced degrees at UVA. That's probably
absolutely
the answer to it.
Is there anything else that we need to talk about here, or have we solved all of the problems that we can in one discussion of the AI Playbook?
Well, I think we've definitely asked a lot of the right questions, which is often the hardest part. Why don't I mention that I'm going to be back on the grounds May 10th, providing a keynote at the Knowledge Continuum, which is hosted by UVA's CMIT, the Center for the Management of IT.
Awesome. Well, good to chat with you guys. It's always fascinating to hear your thinking on some of these complex and very timely topics. So thanks for the opportunity.
Yeah, thank you. But I thank both of you. I think that's a great discussion. A lot of great food for thought.
Thanks for checking out this week's episode. If you'd like to learn more about this topic, we recommend checking out Eric's new book, The AI Playbook, which is on shelves starting February 6, 2024. If you're enjoying UVA Data Points, be sure to give us a rating and review wherever you listen to podcasts. We'll be back soon with another conversation about the world of data science. We'll see you next time.